So whenever we take a slope, to us, we're going to call that a derivative. Okay? And in your notes, to take a derivative, there's kind of a complicated process involved, the backstory to it, which, remind me again, who's in AP Calculus? Okay, so you guys are learning the backstory. You're learning the backstory to derivatives?
No, we're learning.
Joey, AJ.
We're still in limits.
Our test
We're
is
taking a
full.
test today. Yeah.
Your limits are
He's also in our class. Yeah.
good. You're right where you need to be.
Yeah.
You're not going to learn derivatives for some time, and you'll learn integrals like in February, but we're taking care of them today.
Okay.
So whenever you take a slope, you're taking the derivative. In this class, what I want you to remember as far as taking a derivative is using a rule.
For the projector.
I'm out. Board's heating up. I want to keep it in the same variables as your textbook, so that way when you read section 2 of chapter 2, it will be familiar to you. Come back.
I agree.
Ryan, UCT. So if I were to find the derivative of u, here's where I would. Thank you for asking that question. It is completely made up. These variables are just completely made up.
No, not the variables. How you transfer it from the other.
Before we get into that, actually we don't even care about why does this work. We're just going to go with it as a rule. Like, we know 3 plus 4 is 7, right? And we know 3 times 4 is 12, right? And we get the idea of how
Attention
that.
teachers and students, we're going to be doing fire drills here in just a minute. So group 1 at 7:30.
Virtual fire drill.
3, 5, 10, and even 40. So please be ready in just a moment when we pull the fire drill.
Listen,
Others
it's
still
gonna
need
get
the
really
portable,
loud.
please stay where you are.
Can I carry the tablet with us, recording? I think it was there.
No, we're not in group 1. We're at the end of the period. So this rule right here, I want you to spend 2 minutes right now with your partners and figure out a pattern between these two. So this is where I started,
That's what I was trying to ask.
and this is, you're asking
Is that
about
a U or a V?
you.
A U.
Just add the tail.
Add a snake on it. That is a beautiful.
And that's how I between U's and V's, so. Oh, it's worse.
Okay, pattern, guys, First replay.
The buildings that I just announced, please move to your stations for your fire drill. Again, this is a drill. Please move to your stations. Thank you.
So U equals CTN. So we can identify the pattern.
The pattern to go from this
It goes from equation 1 to equation 2. Yes. How do you
So the
I
pattern.
wouldn't know that.
You on the left, the C on the right.
How did I do it? What did I do?
No idea.
What did I do? To get from this to my answer, I took the derivative, that's what I'm going to call it. Joey, please. I took the derivative of u with respect to t. So when you see this notation, the derivative of u with respect to t, du dt is just, this is the rule, these aren't physics variables, this is a math equation right here, okay? So to get from u, to take the derivative of u, I'm going to take n and move it out front, and then c, t, n minus 1. So step 1, to take a derivative, move your exponent out front. Thank you. Step 1, take the exponent and move it out front. Step 2, subtract 1 from the exponent.
You take the one from the exponent because you moved it out front.
Yes.
Sorry, I'm just trying to clarify.
And remember, all this is finding the slope really quickly of a function. So if we're looking for the slope of this point, then we know this line equation is y equals mx plus b. Our slope is going to be that. We're going to do rise over run and be good. What's the equation for this line?
X squared.
X squared. So how do we find the slope of this?
You have to do the thing where you zoom in really close.
You're going to take the derivative of y with respect to x. So step 1,
Would it be dy over dx equals x to the power?
Equals x.
Stop.
with this, let's take a step back. We would read this, the derivative of y with respect to x, right?
Yeah.
So this is the y-axis and this is the x-axis, okay? Just so we have that clear. So we're going to take the derivative of y with respect to x, and we'll get step 1.
Move the exponent out front. 2 at the power of 2 minus
2 minus 1, which is?
1.
Do we have to write the 1?
No.
That's it.
So that's the slope of
At this
the.
time, all portables and buildings that have evacuated, please go back inside. Thank you guys very much for the first drill. The second one will be about 8:07. Thank you.
Because this one is a function, we're moving that. We're keeping the function, but now we're able to use this to determine our slope, our delta y over delta x at any x. So if we now wanted to find the slope at x equals 3, then we would plug in the slope here and it would be 6.
Can you clarify that?
Whenever the point of doing this is so that way we now have a function that will give us the slope. So we took the function of the entire line and we condensed it, we zoomed in really, really close to get this to a straight line. And now this is our dy dx. This just means a very small piece of y. And when I say very small, I mean infinitesimally small piece of y.
Infinitesimal?
Infinitesimally.
Okay.
Infinitely small.
Yeah.
Slower
but
than the
like,
naked eye. Let's put it that way.
So that D out in front. When we see this, we're thinking it's a very, very small rise and a very, very small run. And that's because we have zoomed in on this graph so much.
That is a straight line of something.
It's now a straight line, and we can then use this function to determine that rise over run. And so we would, if we were looking at x equals 7,
It'd be 14.
it would be 14. Because all we're going to do at this point, now that we've taken the derivative, is just take our number and pop it in the equation.
And then 8 would be 16.
Right, right. And obviously it's going to get a little bit more complicated than that.
And then 10 would be 20.
Okay, we don't put that.
I said, remember, the slope is a derivative.
21. The derivative of a x versus t graph is dt over dx.
No, give me just a word. What does it give me? No.
Slope.
This phrase was on the board yesterday. I told you to memorize it, except it was slightly different. Did you write it down? Kenneth? Very good. Yesterday, the sentence was the slope of a x versus t graph is velocity, right? Well, we said slope and derivative are the same thing. So therefore, the derivative of a x versus t graph is velocity.
Interesting. Yeah.
Yes, it is definitely in your notes.
Yeah.
Okay, so this is where we're headed. So that means our velocity equation that we know is delta x over delta t can now be written in derivative format. dx dt. The derivative of your position with respect to time.
Making sense.
Good. Then I'm probably messing it up.
Playing the dim switch over here.
Okay.
Playing, okay, up, down, in.
Good. Good. As long as we're getting some of those ups in there. Jorge, good? Okay, you're being quiet and you're kind of out of frame.
I'm having some epiphanies.
Good. Good, good. Keep them coming. Let me give you practice. Let's. X sub I, that is our initial x, that's our starting point. X sub f. Good. And then we have t. If we started at 0, we ended up at 12 meters, and that took us 3 seconds.
Uh-huh. You would have moved 4 meters.
Right. Right.
Yeah.
So give me an equation for
30. Oh, 3. 30 t.
What?
I thought he was gonna make like 34 or something, but it's 30 t.
what's that?
You're pulling a Mr. Clock. Mr. Clock's like, you know, just stop.
Oh, I'm trying to make sure I'm writing.
For like 20 seconds. I'm like, oh.
He's like a genius.
I'm still like,
Mr. Clark will stop, do the entire equation in his head, and then give it to you. You know the answer.
After making it up, of like, find the limit of x cubed plus 4x over.
Not larger numbers. What we've done is we've now put a function in for a variable. So whenever you have this mess, where obviously it's just, you can't, right?
Well, then that one's insane.
Two binomials.
Okay. Let's,
Polynomials over each other, so find the limit in your convenience.
Well, it's probably equal powers. You know that it's all in easy to have.
Yeah, we just have to do it.
let's say we're given velocity
And you also
is equal to this.
Okay.
Find the speed at 2 seconds.
I know, but
Can I use my graphing calculator to graph it?
oh, bet. Oh my god. Okay, so y equals clear
Wait, so do you want us to do
3
derivative?
at
Mm-hmm.
3
Oh.
seconds table derivative.
I think I'm getting ahead of myself.
Start, you said how many seconds? 2
I'm
seconds?
definitely getting ahead of myself. Yeah. Go ahead, fight with that.
24. 24, I'm guessing meters per second if we're measuring in meters. How'd I get that? I did this.
Plugged in the equation and you got the slope at that specific point, right?
Yeah.
Good. Let me do some actually here rather than just throwing out numbers off the top of my head. I definitely wrote that wrong. Sorry. All right, so there's a position graph of an object. That's easy. Yeah, go ahead and do that.
Okay, I still don't understand myself how to write position graph.
At t equals 1
Oh, that's
half,
easy.
that gives the object's velocity. Okay.
Wow, this is very hard.
Right. Got it?
Yeah.
Good. What is it?
C.
Three.
It's C.
This is just a straight line. So straight line just tells us this rise over run, right?
Yeah.
We don't need to use any calculus.
B. That's
Rise,
right.
20, and the run is 1, right? Starts from 0, goes up to 20, goes over to 1. Or goes over 1. That's our slope at 1.5 right here. Nope, that's going into integrals, velocity versus time, displacement. All right.
Deceleration. Slow deceleration.
Actually, let's just do this.
It's so weird, I'm hearing something that we don't understand.
I got from out amongst the people without my mask.
Yeah, what the heck's about it?
What's up? All right.
I didn't think we were gonna do that.
Two x 3 plus the constant?
Two calculus is
You didn't get one? Okay, relax.
Nick was the only one that got
Who's still waiting for one? 1, 2, 2. I don't know how I missed that. They're printing, but I'll project it. All right, so this little packet that I've given you,
Goes from page
It's a
21 to
very
60.
busy numbers.
This gives you all of the information you need to come across, to handle any of the derivatives that you will need to take. There's also practice with graphs in the back. Ah, thank you. I gave you guys it?
Yeah. We're in this class now.
Gabe. Gabe.
Get out of here, loser.
Gabe. All right, so it just looks slightly different. But it gives us better examples than me just throwing out numbers. So we're taking a polynomial, which has multiple x terms. And then we are going through and taking the derivative of each of those if we were needing to. Okay? So it sounds complicated. So without reading the rest of this, let's work together on taking the derivative of that. So let's say 2x to the fourth plus 5x cubed minus 4x squared minus 8. We're going to start here. Give me the derivative.
8x cubed.
Good. How did you get 8x cubed?
Take 4 put it in front. And 4 minus 1.
Good.
So 15x squared minus 8x, that's it, and then minus 8.
Ah,
Or does that even qualify?
it does not qualify. It is whenever you have a constant without any x term, it becomes 0. Because if we were to graph just this
It would be-
as a function of time,
Yeah.
it's going to be a straight line. And what is the derivative of a straight line?
0.
0.
Okay, I can understand where you're getting the derivative from.
I smell the
Okay.
The slope derivative.
So let's flip. These are all your examples. Flip.
flip.
Go to question number 27.
Flip right to it. I literally wrong. There are
I wonder what the answer is.
Everything, this is a workbook that we use. Everything is related to monkeys.
related to what?
Monkeys.
Monkeys and bananas. That's it.
What is this? It is partial monkey and banana.
What's our derivative?
30x to the power of 4.
Is it?
No,
Why not? What is it?
because you said it wasn't.
Doesn't look right?
It doesn't
I
sound
got no
right.
idea. I'm lucky star.
All right, hold on. Peyton, walk me through. How am I going to take this derivative?
5 times 6 is 30x.
Then what? That's step 1.
4.
That's what he said.
Yeah, what's your job?
Yeah. And look, if you were right, it sounded good. Yeah. The box is low, it's hard. At least I can't cheat now.
All right, the next one.
The answers are
dt dt.
yeah.
They're the same thing.
Okay.
James, you're so smart.
Bro, you went the wrong one there.
What about this one? 29.
Pretend the answer isn't there.
Yeah, well,
Negative 6x.
the reason why I like the answer to be there is so you can work on this individually and check yourself and then say, oh, I don't understand what I'm doing. Because if I just give you problems and you're just chugging along thinking you're doing the right thing and you're messing up, that's bad news because you're getting into these really bad habits. But if you work out a problem, even if you, I mean, these you don't, it's just thinking. So there's not a lot of work that goes on. But I promise you, as you can see, it gets a lot tougher quickly.
Yeah.
Okay, so we're gonna use these packets. We'll call them monkey physics, and it will help us get into the good habits as we work problem solve.
I have an answer.
All right, I don't want an answer from you. Dara, walk me through. Good, good, good. All right. Shh,
Break
shh.
the rules.
Step one. Go ahead. Walk me through it.
So when you move the negative sign, like, to the front of the two?
You multiply by the coefficient. Yep.
Which is?
Which now that we're a little bit better, we can put that in as our step one and speak a little bit more mathematically. I don't know, it just makes me feel smart just to say that.
Yeah.
So we're going to multiply our exponent by our coefficient, which is what?
-60.
Dara? Dara? What's this?
I messed that up.
That's all right. Now what?
And then x,
Mm-hmm.
and then negative, would it be negative 2?
Be -4.
Oh. Get negative more.
Good, good.
Yes, Darrow.
Good job.
We got through it.
Yeah. So what? So what? Who started clapping? Do I have a mirror?
Yeah.
There's a mirror back there, mirror over there. We're in the physics class. We got mirrors up. Who started clapping? Who started that nice little round? It was you?
I did not start it. Everyone started clapping back. You made it. Wow.
It was you. All right, Nick's gonna walk us through number 30. This Nick, sorry. Go.
Okay, so when you move the 6 to the front, so like the front of the, does it matter the denominator?
Okay, that's a really good question. It's in the denominator. This doesn't work for a denominator.
Oh,
So we need to get this out of the denominator. Remember how to do that?
Why not just turn it into a negative exponent, 3 times t to the negative 6?
so now
He
we
wrote that
can
down.
do the,
He did that. I did that.
Nice. You did that? Good.
It really was.
Jace, you did that?
I did that.
Nice job.
I know.
Now it's easy,
Now
right?
it's a lot easier. Now you can do -6 times 3, which is -18 t, and then you subtract 1 to the 6, which makes it -7.
Is that the right answer?
Yeah, it is.
Let's go, Nick. Let's go, Nick.
That makes sense. Okay, so you make it-
This is just calculus. Like, this is not even first month calculus. Switch your schedules. What period are you guys taking AP calculus?
We're taking forward.
Fourth period. Get rid of your fourth period. Go into AP calculus. Just don't lose this period. What's that? Seriously, it will help you in here. It will help you to know calculus, but it'll also help you college entrance, your applications, GPA. You get Mr. Clark. There's a lot of benefits. French guy do math. Who's that? Oh, British. You guys.
We're literally not.
Yes.
Do you have to take pre-calculus first, or can you just jump right to it?
You guys take pre-calculus. Joey. Walk us through 31.
31. Alright.
Where's the?
It's the only way to do this. Alright. The derivative in respect to x.
I think AJ should walk us through 32.
Yes.
Yeah, AJ's got it. His brain is weak.
You're walking us through 32.
Alright, so you know, when you have a plus and addition, which you'll never probably get further than that. Oh, actually, yes, you guys are. The rule is you multiply the exponent times the coefficient, and then you subtract it by 1.
Did you get that by reading the board?
Me? No, I got that off the top of my head.
Oh, good.
I took calculus
Yeah,
for
it was
you.
on top of your head.
No, okay, that was kind of funny. Okay, but I didn't mean to do that. That was pretty funny. All right, but no. So you do that. It's gonna be 24. All right, x to the 7th minus 30 x to the 4th plus 18 x, and then that will just go to 0. If you have a constant, you just get rid of it and it disappears into Narnia. So yeah. And then that's legit it. That's like the answer. And for this one, come into...
No,
I was helping them.
No, we don't.
We don't need help. We don't need you, Joey. You I will be coming to you soon.
You will literally just...
Alex!
That's kind of tough. You guys talk.
Walk us through it.
Yeah, it's very interesting.
It sure is, right? Does this, do these rules work?
No.
No, because there's a fraction, right? And there's a radical, so we need to get rid of both of those at the same time.
Free copy, we're doing that.
Good, good.
Alrighty.
Go ahead. So rewrite this in a way that gets rid of your radical and fraction. You can do it in one step and get rid of both of them. Hold on, I know. Good,
One time I actually feel successful in this class.
good, good. No, I want you. Come on, what would you do first? How would you get rid of the denominator? Gabe, stop. How would you get rid of the denominator? All right,
Multiply by reciprocal.
keep going. Yeah, what? Come on. Yes. Yes. Give me one step. What do I do? Okay. If I were to have 3 over 4,
Yeah.
how do I get rid of that fraction? Like just in general terms. How do I make that go away and turn to 1? Okay, multiply by 4 over 3. What do we call that?
I was right.
Reciprocal, right?
Multiplying by the
So
reciprocal.
by multiplying by reciprocal, that's going to get rid of your fractional form. Yeah. But
Didn't have that in my.
in this case, what we'll do with this is we're going to rewrite it. An often forgot equation is that a square root is equal to x to the 1/2,
Yeah.
right? And if we were to inverse this, it would be x to the negative 1/2.
That wasn't what I had in mind.
I feel like the way you wrote that was really trying to represent what you were trying to say.
How would you write it?
I would write 1 over the square root of, what is that, u? Yeah, is equal to x to the negative 1/2 over 1, so you know it's a fraction. Do you understand the process that you're flipping it over? Yeah, just the way you wrote it was weird. Yeah.
I mean, I didn't really take the reciprocal. I kind of multiplied it by square root of u
Okay, so by multiplying by square root of u by the square root of u, that's getting rid of that and getting rid of that. But so you're multiplying like that, and that kind of frees it, right? Well,
because then it would be, the bottom, the denominator would be u, and then you would have a square root of u on top.
Mm-hmm.
So would that work?
Then you would have to bring the bottom part up and make it a negative exponent, and then you'd have two multiplications of u, and then you'd have to do
Okay,
the
that's what
addition of the exponents of those two, and then it would probably come out to the
Yeah,
same thing,
I'm
u to the
already
negative.
It's you can get there, but you're going to have to keep going.
Okay. So pretty much just open it.
Two things. Number one, when dealing with a fraction, inverse, and then square root is to the 1/2 power.
No.
Okay? Remember that square root is the same thing as the 1/2 power. That will come up repeatedly throughout the year. And this thing looks incredibly horrifying.
No, it gets twice as bad.
But if I rewrite this as u to the negative 1/2, negative because it's in the denominator, to the 1/2 power because of the square root, over 1, then that just becomes u to the negative 1/2, not mu, just u. Now can I take the derivative of that?
Yeah.
Okay.
Negative 1/2 u to the power of negative 1.5. Yeah.
That's ugly.
I'm not used to writing the little thing.
But that's not what they said. Or is it? If you actually write the radicals instead of.
And if, you should know
What?
how to simplify it, put it back into terms of like square roots.
That's
So
just
how do
ugly.
we put it into, how do we squeeze it back into a square root? Let me stop you right there. In math class, you're going to have to put it back into a square root. In physics, if you leave it as that, I'm good. AP will be good, you're good.
Knowing how to go back and forth is good.
Knowing how to go back and forth is good. When do you learn about this square root equals 1/2 power?
A long time ago, I just forgot.
Yeah.
Okay, just making sure, just making sure.
Algebra 2, most likely. Well, or, I don't know. I was not.
Oh, I was the one in 7th grade. I remember.
Would it be negative square root of 2
But it was also
with u as the radical?
worst teacher.
Negative square root 2? No,
Until she got arrested for like
because this is
Yeah.
negative u over 2, and the u is to the negative 3/2. So this is,
Oh, okay, I'm
Your
thinking
square root.
because the coefficient is an exponent.
Until 4th grade. For 2 years.
that was a hairy one. That was a hairy one.
That's a weird one.
Ah, nuts. If I were to do this process in reverse, we have that, and we have that, which we now know is a derivative.
Yeah.
Well, if I have a velocity versus time graph, and I want to know how far did I travel during these first 2 seconds, how could I possibly do that? What is my displacement during the first 2 seconds? This is a question that is very commonly asked. We know that to go from a position versus time graph, there we go, now the graphs match. To go from this graph to this graph, we took the derivative.
Yeah.
How do we go from this graph to this graph?
Wouldn't you just divide the velocity by the time?
Mm-mm.
Or time by
Or
velocity.
So,
time by
so
velocity?
when you start thinking about this stuff, think about your dimensions or your units.
I think it knows.
Velocity is measured in meters per second, and time is measured in seconds. Right?
Yeah.
If we divide these two, then we're dividing meters per second per second. Dividing is rise over run.
Attention teachers and students, we are now going to.
That
be
tells us our
conducting
next
second
graph.
Fire drill for group 2. This is going to be building 6.
That's us, guys, so
7,
pack up.
8,
This is
9,
how we get our acceleration versus time, and then we can graph that.
7, 8, 9, and the odd intervals. When you go out for the drill, on this one,
So if we take the derivative of velocity with respect to time,
when we release
we get
that
acceleration.
on the side, you will be going to your
But
second.
we need to go backwards. To do that, we're going to take the anti-derivative.
There's an anti-derivative.
You're joking.
We keep this paper, right?
Yes, keep that paper.
So instead of dividing, you're just multiplying it by. So instead of
Rather than
having-
multiply, you're going to divide and add.
Yeah.
It's this process, but
Is that in here? Anti-derivative? Okay.
it's the next page. Oh yes, medical cards. I need your medical cards before we go. Pop them right here on the table.
Oh, I didn't do that.
My parents
I'll
said
have
that
them
you can't.
Monday.
Tuesday,
Oh, Tuesday.
I won't be here Tuesday. Your assignment will be on Pivot Interactive. So if you have not yet signed up, sign up.
I'm having trouble paying.
Pivot Interactive. What's that?
Yeah, it says it wants to pay a fee of $5.
$5.
Do you have to do that? Okay.
$5. Yes.
What was I gonna ask? Did we turn that into the sub? Can we turn that into the sub?
Yes. Yeah.
Okay.
Sub will turn it in.
My parents are having trouble with the fee,
Okay.
so we might, nobody will do it
Okay.
until this evening.
That's fine. That's fine.
School Wi-Fi is
Oh, yeah.
What's that?
school Wi-Fi is in the cell data service.
Yeah. No, just do it this weekend. Oh yeah, press stop. Thank you.